Over the answers to worksheet 2 in your purple notebook. Let's see, worksheet 2, I'm flipping right now, probably just like you are. Worksheet 2 is on page 117. And pause if you need a second. So the first couple questions here are all about finding a molar mass. Our two relationships with moles. The one we use a lot is the periodic table. Those masses on the periodic table are called the molar mass. So we got to go find some masses on the periodic table. So we have the formula for number 1, K2C4H4O6, and we need to go grab the masses. So I find potassium. I'm multiplying it by 2 because there's 2 of them. We find carbon. We multiply it by 4 because there's 4 of them. We find hydrogen, and we find oxygen. We're multiplying these by the amount there, and we add them all together, and then we have the molar mass of the compound. It's not too terrible. You just have to be careful, right? Okay, let's look at number 2. Same idea. We're doing the molar mass. So I find gallium. Boom. There's 2 galliums. However, after the gallium, there are parentheses around the SO4. And then there's a 3 on the outside. What does that 3 do to the parentheses, these things inside the parentheses? The 3 multiplies everything in the parentheses by 3. So that's 3 sulfurs and 12 oxygens, right? Because there's 4 oxygens inside times 3 is 12. 1 sulfur inside times 3 is 3 sulfurs. And then we can add these all together and get the combined molar mass. In 3 and 4, you had to work out the formula ahead of time. Let me just reveal those 2 formulas. Boom. And it's the same idea. We grab carbon, we grab oxygen, and we have the molar mass. Not sure what that little squiggly is there on the 0. It's supposed to be 16.00. I accidentally typed the wrong thing. And then in number 4, we have copper nitrate. That's 1 copper, 2 nitrogens, and 6 oxygens. When we distribute the 2, that's 2 nitrogens and 6 oxygens as we go through that. All right, so that was the first page, finding the molar mass, going to the periodic table, and adding the masses together. Let's go on to number 5 and number 6. In number 5, we're supposed to figure out how many grams these things are. Number 5, we really don't need to do too much. They ask for the mass of 1 mole of calcium chloride. So we just go to the periodic table and we add the pieces together because that is 1 mole. You don't have to do anything funny. In number 6, though, they don't ask for 1 mole. They ask for 0.1 moles. Well, we don't have a periodic table that shows 0.1 moles. Our periodic table just shows what 1 mole is. So the first thing we want to do is figure out what 1 mole would be. And, that's what I'm doing here. Is I go to the periodic table. There's 2 irons, 3 carbons, 9 oxygens. We add it together, and we have 291.7. But that represents 1 mole. So I like to use dimensional analysis, where I write down the given, and the given was 0.10 moles of iron carbonate. And then I write a ratio, and on the bottom of the ratio, I need to have moles. Why do I want to have moles on the bottom? We are multiplying, people. We are multiplying. And when we do moles times anything, let's say G over moles, if we do moles times G over moles, the moles end up canceling out in our math, and the only unit left over afterwards is going to be grams, or G. So moles times G over moles, the moles and the moles cancel out because they're on the top and the bottom, and G is the only thing left. And you heard me say that a bunch last class, but it doesn't hurt to repeat myself. It's especially when I'm not there. So we've got the moles canceled out, and the number on top could be a couple of things. But for 5 and 6, we are looking for the answer in grams. So this number here is going to be what 1 mole is in grams. 1 mole is 291 grams. So we're going to multiply 291 times 0.1, and we're going to round. So I got 29 grams of iron carbonate is 0.1. So 0.1 times 291 divided by 1. Cool? Cool. All right. Number 7. We're dealing with particles, and we're supposed to change them all the way to mass. We have 1.47 times 10 to the 23rd particles. You know what? I should probably write that down as my given. Oh, I did. All right. 1.2. I got to adjust something just ever so slightly here. Oh, you can see that for a brief second. 1.47 times 10 to the 23rd particles of ammonium hydroxide. What am I going to do with that? That's a good question. Well, it's not moles and it's not grams, it's particles. So if it's not moles and it's not grams, if it's particles, we're going to use Avogadro's number. And we're going to be able to use Avogadro's number to convert it to moles. Now, where does the Avogadro's number go? Is it going to go on the top or the bottom in the ratio? Well, right now, the big scientific notation chunky number is here on the top. Avogadro's number is going to go on the bottom to cancel it out, right? Now, that's only going to change our particles into moles. And we got a lot of scientific notation numbers up there. We'll talk about how to deal with the math in a minute. Right now, we're just doing the setup. So I've changed my particles into moles because I have particles on the top and the bottom and moles currently on top. But again, this question was about changing it to mass. How do I change moles into grams? I use the periodic table to find how much 1 mole would weigh. And so I went to the periodic table and I found nitrogen, hydrogen, oxygen, and another hydrogen. I added them all together. That's where that 35.05 comes from, is adding them together from the periodic table. And so my units go from particles to canceled out particles and to moles. And then the moles cancel out and go to grams. This is a 2-step question, and we have 8.56 grams. Mr. Murphy, I'm not getting 8.56. I'm getting something completely different. Make sure that when you are doing these big scientific notation things, you put them in parentheses. So I would have typed 1.4 times 10 to the 23rd. I would have multiplied it by 1, and then I would have divided it by Avogadro's number, again in parentheses, multiplied it by 35, and then divided it by 1. The key here is if it's on top, you're multiplying. If it's on the bottom, you are dividing. All right, hopefully that worked for you. Express the following in moles. Okay, let's just write down our given. Always a good idea to start by writing down the given. Here we go. So this time the given is in grams. How do we change grams into moles? We use the periodic table. And so I went to the periodic table and I put together what 1 mole was. I found 10. Let me put 10. That's my periodic table. 10 is 118.71. 2 nitrogens, that's 2 times 14.01. 6 oxygens, that's 6 times 16 grams for oxygen. We add that all together to get this 10 nitrate. And now I've got it set up. I have grams times moles divided by grams. Grams cancel grams, moles don't. But I want moles, so that's good. Then I do the math. 2.5 times 1 divided by 242. Boom. I get my moles. Number 11. Ooh, they've given us particles. So I write down this big chunky number that's in particles. And I realized that I got this big giant number of particles. I got to get rid of it. I'm going to use Avogadro's number to get rid of it. Yeah, that's a good idea. So I did. I used Avogadro's number to get rid of it. I throw parentheses around each of these numbers. Parentheses, 1.5 times 10 to the 26th. Close the parentheses. Times 1. Boring. Divided by Avogadro's number, 6.02 times 10 to the 23rd. Inside parentheses, its own set of parentheses to make sure my calculator knows what's going on. And I get 249. Remember particles, it's just the number of objects we have. It's a huge number of objects. That's why we work in moles on a regular basis, because the number of objects at the atomic size is just insane. So we have a different way of talking. It was where you have moles. All right, more ideas here. Number 12, we have moles. We're trying to find atoms. 13, we have grams. We're trying to find atoms. 14, we have grams. We're trying to find atoms. 12 is not bad. Write down the given. It's in moles. So to go from moles to atoms is just a straight up use Avogadro's number, nothing too fancy. And you cruise right through that one. Because it was in moles, we got to go immediately to using Avogadro's number. Why didn't I use grams? Good question. It had moles and particles in it, moles and atoms. So I didn't need to add the grams in there. There was nothing about grams in number 12. Whereas in number 13, the given is in grams. Oh, it's in grams. If the given's in grams, I can't go directly to particles. I have to change those grams to moles first. I got to go to the periodic table and figure out what C2H2 weighs. And that's what's going on down there. That's 2 carbons and 2 hydrogens added together. And then I can take the moles, just like I did in the previous one, moles to particles. I'm going to do moles to particles right now using Avogadro's number. And 14 is pretty much the same thing as 13. You have grams. You use the periodic table to change it to moles. You use Avogadro's number to change it back to particles. All right, I'm going to go on to the next slide, but if you need to pause here, if you need to catch up, that's totally fine, okay? All right, welcome to some slightly new questions. Here we're doing percentages. We're supposed to do the percentage of iron and oxygen and iron oxide. In order to do this, we first need to know what the total mass is of iron oxide. So the first thing I did was I went to the periodic table here and I found what Fe2O3 weighs. 2 irons plus 3 oxygens is 159.7. That's the molar mass, if you will, of the compound. And then I want to do the percentages. This is not too bad. We're going to take the amount of oxygen. Now, the oxygen value is not 16. It's 16 times 3 because there are 3 oxygens in this. So this is 3 oxygens divided by the total. And then with the iron, it's going to be 2 irons divided by the total. And you know you've done it right if these 2 answers add up to 100%. All right, the percentage should add up to 100. The exact same thing is occurring in 15B, except it's for NH4Cl. So first I found the total, NH4Cl, added them all up. And then I did the amount of nitrogen. There's only 1 nitrogen, so I did 14 over the total times 100. And I got the percentage nitrogen. How many hydrogens are in this compound? That's right, there's 4. So I would do 4 hydrogens divided by the total to get the percentage of hydrogen. And for chlorine, there's 2 ways we could do chlorine. We could do 100% minus 26.19 minus 7.55. That would work. we'd have just the chlorine because that's the only thing left, or we could just do the chlorine, 35 divided by 53, and get the remaining percentage. Hopefully those add up to real close to 100. I'm nervous. I'm going to add them together. Let's see, 26.19 plus 7.55 plus 66.26. Exactly 100. Yeah. I'm pretending like that didn't happen. My number 16, we're doing percentage, but this time we're doing it from some data. So Mr. Shangra burned some barium. It was 61.9 grams. After it was burned, it was 69.1. So it got a little heavier. And when things burn, they gain oxygen. So it gained 7.2 grams of oxygen. So here's the percentage that is barium. It is the mass of the barium divided by the mass of the barium oxide. And here's the percentage that's oxygen. The mass of oxygen divided by the total mass. And again, I got these two percentages, but how did I get the mass of oxygen? I just subtracted the first two values to figure out how much more was oxygen. All right, now it's time for the empirical formula process. To solve empirical formulas, we take the data, we go through 3 steps. We call these steps the mass to mole, divide by small, multiply to whole. And the word small is actually smallest mole, as we'll see in a second. So first I take the data and I do the mass to moles. I do the mass to moles. I do the mass to moles. And this is just taking the mass and using the periodic table and converting it to moles. All right? And each one's going to be a little bit different. That's okay. So I took the data, 26.6, 53.4, and 38.0 grams, and I converted them from masses into moles. That is step 1, converting the masses all into moles using the periodic table. Step 2, divide those by the smallest moles, also known as the smole. Which one of these answers is the smallest number of moles? The smallest moles, the smole. I believe that the smole is 0.680. So we're going to divide by 0.680. We get 1. We're going to divide by 0.680. We're going to get 1. We're going to divide by 0.68. We're going to get 3.5. Woo! Look at that. Okay. So 3.5. We currently have a formula that looks like this. For potassium, there's one of them. For chromium, there's one of them. For oxygen, there's 3.5. Ew, that's not a whole number. So the last step is multiply to whole. And I wrote get to whole, but let's just write multiply here. Multiply to whole. We're going to multiply these 3 numbers, 1, 1, and 3.5, and try to get them to a whole number. And oftentimes, we are multiplying by 2. That is not uncommon. Occasionally, it's by 3. But in this case, when we multiply by 2, we're going to turn the 3.5 into a nice whole number, and as well as the other 2. Boom. So K2CR2O7. So those are the 3 steps. You take whatever your masses are, you convert them to moles using the periodic table. Then you divide by the smole, also known as the smallest. And if necessary, multiply to get to whole numbers. And we have figured out the formula for potassium dichromate, K2CR2O7. Nice job. So this is how you turn data into equations, into formulas. Similar idea here, except this time we know the mass of the compound. So if we know the mass of the compound and its percentage, we're going to go ahead and apply that percentage in number 18. So if it's 56% phosphorus, let's figure out what that would be. And that's what I did first. I did 220 times 56%. I did 220 times 43%, and I found the masses in terms of using those percentages. Then I'm going to do the whole mass to mole, divide by small, until I get nice numbers. So let's divide these and see what we get. We're going to divide this by the periodic table, divide this by the periodic table. And look, we got two really nice numbers. Two really nice numbers right there. Oh, let me write that as a formula. I forgot to actually include the formula in there. Let's do that. So this would be P subscript 4, O subscript 6. Man, that is small. Let's make that bigger. Make it chunky. There we go. Yeah, that looks like it could be the formula. We need to check and make sure it is the formula. We have the mass there. The mass might be 220. Let me grab my calculator and make sure that P4O6 is in our periodic table. So P4, let's see, phosphorus is 30.97, so 30.97. Oh, there's 4 of them. I'm going to multiply that by 4. And oxygen is 16. I'm going to multiply that by 6, and I got 219.88. 219.88. I'm going to call that a win. 219 is pretty much 220. We have found the formula. Again, we used the percentages right on the mass of the molecule to simplify some of the steps. And our last slide is another empirical formula. Again, we have percentages. If we just have percentages, we can pretend that they are masses also. And so instead, I used the percentages as if they were masses. So I just said 52% is 52 grams, 34 is 34 grams, 13 is 13 grams. And then I'm going to go through those same 3 steps. Mass to moles. I wrote down my masses. Let's convert them to moles. There we go. I went to the periodic table and I looked up carbon, oxygen, and hydrogen. And I got these mole values. All right, so we've converted the mass to moles. The next step is to divide by the smol. Who here is the smallest? Who is the smallest? This number is the smallest. So that is the thing we're going to divide them all by. Because it's the smallest value, we divide them all by that value. Look at that. We divided them all by that value. And we get a 2, a 1, and a 6. So it looks like our formula might be C2, because the carbon had 2, O1, because the oxygen had 1, H6, because there were 6 hydrogens. And we have figured out what this formula might be, C2O1H6. I think there's a mass given in this question as well. Why don't you check and see if this formula has the same mass? All right, you have finished worksheet 2. You guys are going to take a practice quiz where you practice some of these ideas. I hope it goes well and hope you guys have a great day. Talk to you later and bye.